So on the basis of energy band diagram, how we differentiate between conductors and insulators is that when we have to talk about conductors, suppose the conduction band is up to this point. Okay, this is conduction band. So valence band actually overlaps conduction band. Alright. So this is the difference. This is the energy band diagram in case of conductors. But in case of insulators, how can you explain the concept that valence band is actually overlapping conduction band? What do you mean by conduction band? Those free electrons which are completely separated from the atom and which are free to move in interstitial voids. But valence band corresponds to those electrons which are still attached to electrons, that is, they are in valence shell. So how can we say valence band is overlapping conduction band? That is because these valence electrons are in so much valency state, they are at a so large distance from the nucleus that even with the application of smallest electric field, they'll start drifting in the direction of electric field. No, actually in the direction opposite to electric field. Why? Because electrons are negatively charged, they'll drift in the direction opposite to the applied electric field, right? So this is the energy band diagram in case of conductors. In case of insulators, if this thing is valence band, conduction band will be till here and there will be a very large energy gap between valence band and conduction band. So it's not like that we cannot give this much energy level to the valence band electrons of insulators so that they can jump to conduction band. We can give that energy, but the problem is that suppose this caps atom. This is a plastic, we know that this is a non-conducting thing. So suppose I want to give this much energy to the electrons of the valence electrons of this thing. What will happen? The energy is too huge for this electron to accept only entirely. What's going to happen is when I give that large amount of energy, that energy is going to be accepted by complete atom and the whole atom is going to vibrate vigorously, which will result in the melting process. What is atom doing? Atom is actually breaking all its bond with associated atoms. This is what is being done by all the atoms and we will see it physically melting. So that energy when supplied to the electron will be absorbed by complete atom, and in this way the whole atomic structure is going to be destroyed. So that way this whole solid state is going to be destructed. So that means the solid is going to lose its entity and it will melt. So that is why we cannot give this much energy to insulators, and that is why insulators do not conduct electricity, because there are no free electrons in the conduction band. So this is insulators. Now there exists a third type which exists between conductors and insulators, that is semiconductors. In case of semiconductors, we have valence and conduction band, but there is a very small energy gap between valence band and conduction band, and this energy gap can be achieved even at room temperature. So that is why this category was separated from conductors and insulators and now it was referred as semiconductors. So what is semiconductors? The group 14 elements having valency 4, silicon, germanium, etc., gallium, arsenide, right? So this is the difference between conductors, insulators and semiconductors on the basis of energy band theory. Now we are going to study in detail the theory or the properties of semiconductors. Okay, so let me give you a brief representation of the semiconductor family. Semiconductors are of two types. One is pure and another one is obviously impure. Pure ones are called intrinsic semiconductor and the impure ones are called extrinsic semiconductor. This semiconductor is classified into intrinsic and extrinsic on the basis of presence of impurity atoms. Why do we add impurity atoms? Yes, we deliberately add impurity atoms into intrinsic semiconductor to convert them into extrinsic to enhance their electrical conductivity. We are going to study about that as well. So this process is called doping. What is doping? It is the process of deliberately adding impurities to enhance electrical conductivity of intrinsic semiconductor. Adding impurities. What is this word deliberately means? This means by will but in a calculative way. So it is it is kind of a risk, but it is done in a very calculative way to enhance the electrical conductivity. Now, on the basis of doped atom, that is, if the doped atom is pentavalent or trivalent, the extrinsic semiconductors will be classified into two further types. One would be negative type and another would be positive type. So negative ones are called N-type semiconductors and positive ones are called P-type semiconductors. So this is the complete distribution of semiconductor. That is, they are pure intrinsic, they are converted into extrinsic by the process of doping. Extrinsics are of two types, negative and positive, which is called N-type and P-type.